So now we are into composite functions, which is simply functions of functions, and they're not really too tricky. The only thing is that sometimes when you're writing the domain of the composite, you really must remember to consider the original domain. Anyway, you might not believe this, but they're super interesting and really important. They're used absolutely everywhere, absolutely vital. So let's get started. I'm going to tell you a story about George the astronaut, who is lucky enough to get to go on the Juno 2 mission to Jupiter. Now, can you see where Jupiter is on my little picture? And up here, I'm just going to sketch in Jupiter, the space probe. You should have a look at the videos on that on the space probe. It's amazing. Anyway, in order for the scientists to make all the landings safe and everything, they need to know how much the astronauts are going to weigh when they are on Jupiter itself. Now, Jupiter is a huge planet. It's a giant planet. It's so big it doesn't even orbit the sun. Now, the astronaut's actual space suit is 12 kilograms. It's really, really heavy. So we've got to figure out how much the astronaut is going to weigh when he lands on that. So let's just call this this function of the weight of the astronaut g of x, g for George, there you go, who's the first astronaut. That's going to be his weight, x, plus the 12 kilograms, that's his suit. Because Jupiter is so big and such a dense planet, the gravity is like 2.5 times greater than on Earth. So we've got to figure out, first of all, what the astronaut's mass is going to be. So in order to do that, we would divide their weight by the Earth's gravity, which is just 9.1 meters squared per second. Well, that's close enough. And we multiply that by Jupiter, which, as I said, is really massive. It's 224.79. We'll go by that. And that's going to be our f of x. That's going to be the weight when you land on Jupiter. That simplifies down to 2.53x, x being the weight of the astronaut. So to get a formula for the weight of an astronaut landing on Jupiter, which takes into account the gravity and the weight of his astronaut suit, we need to do the composite function of f and g. And that could look like either of these two equations. Function of g of x. So in order to get the entire weight, we need to take this and put it into this function here, into that x. So this is what the equation's now going to look like. Think about it as the astronaut is getting into the spaceship and off he goes. Or you could also think about it as when you see a composite function, you think carefully about this outside one, okay? This is what you're going to do. So there's two ways to think about it, but I would think about the astronaut getting into the spaceship. So this is going into this. That's just one way to think about it. Now let's calculate it. So here are the two equations, f of x and g of x, and the function of x, this is your input. So you need to input this, and that's what I end up with. So let's just solve that. 2.53x plus 12 times 2.53, 30.36, and that is our equation. So I could actually plug this in and tell you how much you weigh on Jupiter plus with a spaceship. So so you might actually see something like that. So for example, you might be asked to give a specific value. So let's go with my weight on a good day, and then I can find that out straight from the equation. So it's 2.53, my weight, 68, plus 12. Let's just figure that out. Oh my goodness, is that true? 202 kilograms? Hang on a minute. Well, I totally blame that on the spacesuit. It's just way too heavy. My lungs are going to collapse if I ever go to Jupiter. Here are some exam-style questions. The first two are reasonably easy, and then the last one you have to think a little bit. Pause the video here, and I'll show the answers in a little while. In question 1, f of x is 3 of x. F is on the outside, so we're going to feed the g of x into the f of x equation. So that's 3 times x plus 2, which equals 3x plus 6, and that's the answer. Now part B asks you to find the function of g of x of 4. So you just simply feed 4 into your function of g of x equation. So that gives you 3 times 4 plus 6, and that's your answer. Question 2 is asking you to find the function g of f. So now you've got g is on the outside. G is your rocket. Now if we look at g, we can see that g is 2 times whatever the input is. Okay, so that means this is going to be our input this time. That's going to go into there. So now g of f of x is equal to 2 times x cubed minus 4. Okay, so that's 2x cubed minus 8. Now I can substitute in the negative 2 because that's the equation I have. So therefore g of f of negative 2 is going to be 2 times negative 2 cubed minus 8, which is equal to 2 times negative 8 minus 8, which is equal to negative 16 minus 8, which is equal to negative 24. You could also have done it the other way. You could have started directly by putting this into this function here. So f of negative 2 is equal to negative 2 cubed minus 4, which is equal to negative 8 minus 4, which is equal to negative 12. Then going back to g of x, you're going to put g of f of negative 2 is going to be 2 times negative 12. And that also gives you negative 24. So you could have approached this in 2 different ways. This question number 3 asks you to find the function of h of g of x. So now you've got h on the outside, so this is going to be the rule we follow first. So that's 3 times your input, and then your input minus 2. So which is our input? That's going to be the g. G is going to come here. Remember, this is where the g is. So let's go ahead and put that in. 2x minus 1, 2x minus 1. So let's now simplify that. That's 6x minus 3 over 2x minus 3. And that's the answer for part A. Now part B says solve this if this equation is equal to 0. Solve that. So let's look at 6x minus 3 over 2x minus 3 is equal to 0. Now, how is this going to equal 0? Well, first of all, this is not allowed to equal 0, because if that equals 0, we have a serious problem. We're going to end up in a black hole, remember? Ouch. So we have to disappear and think about that somehow the way. Now, the way we can think about this, well, if that bottom part's not allowed to be equal to 0, then this must be equal to 0. So 6x minus 3 must be equal to 0. That's the only choice. That means 6x is equal to 3. Therefore, x is equal to a half. In this question, you're earning 0.03% commission on sales over €3,000, and it's asking you which of these 2 composite functions represents your commission. Well, if I look at this first equation, this is the percentage sales, so this x must be the amount that you're earning your commission on. And if I look at this equation here, this looks to represent your total sales minus the first €3,000 that you obviously don't get commission on. So let's look carefully at this first equation and see what it actually looks like. So we've got f on the outside, f of g of x. So that means that we're going to be using that rule to put in our function g. So that's going into there. So that is going to look like that. Okay, so let's just put brackets there. Okay, so what does that equation sort of tell us? Well, that looks pretty good. It looks like we're getting commission based on our total sales, subtract away what we don't earn commission on. So that makes sense. Well, let's have a look at the other one first before we stop there. The next one would be this is going to be the rule, which would, and here we'd have to put 0.03x here. Let's have a look. What does that look like? So that 0.03x minus 3,000 euros. That looks less healthy because here we've got 0.03 based on everything we sold and then subtract 3,000 euros of the money we don't earn on. Now, so that really doesn't make sense. So it's really got to be this one. But if you're a little bit confused, then let's just test it out. Let's say, for example, you sold 4,000 euros worth, because you don't earn any commission unless you sell more than 3,000, okay? All right, so you've sold 4,000 euros, and so you've made, take away the 3,000, which means you've got 1,000 of sales to earn commission on. Okay, so in the first one, let's see how much that would be. 0.03 times 4,000, subtract the 3,000. So that's 0.03 times 1,000, which gives you a commission of 30 euros. Okay, so what happens with the other one? Well, the other equation, g of f of x, is going to be 0.03 times 4,000 minus the 3,000 euros. That doesn't look so healthy because that's 120 minus 3,000. So that means that's negative. That's a negative number. So, I mean, you can't earn a negative commission unless you crashed into the office and broke everything and he docked all your salary and then you still had to pay all the bills. So really the answer, what they're looking for, is that this is going to show you your total commission because it takes into account subtracting from your sales the initial 3,000 euros that you don't earn anything with, and then giving you commission on what's left over. So that's how that works.